I have here the curved end ramp, and I'm going to place it on the table so that the curved end is up front here. And I'm going to note that, as we might expect, if I take a heavy rubber band and pull this thing back and release it, the ramp, or the rail as we call it in this experiment, will slide across the table. If I pull the rail back further, it will slide further. Now what we want to do is we want to see how the pullback of the rubber band is related to how far the rail will travel. So I'm not going to lay a meter stick down here. You wouldn't be able to read it anyhow, but I'd put a meter stick here. I'm just going to use this to represent a measuring device, but I'd put a meter stick here and use it to measure distances. Okay, now I've got a piece of string here that's attached to something solid over there. It's got a paper clip on the end of it with a hook. So I've got a nice hook here. And I'm going to place the rubber band just through one edge of this rail, not across the end, but just through an edge. Okay. Now I'm going to pull the system back until the rubber band is stretched out to some distance. Now this obviously isn't big enough to measure the whole rubber band, but I measure the stretch of the rubber band. And I also note the position of this end of the rail. Then I release the rail, and I make sure I get a good release, just a nice sharp release here. And then I can measure the position of this end of the rail to see how far it went under the force of the rubber band. Then maybe I'll pull it back the same, measure the rubber band again. And of course I'm going to record these measurements. Okay. And release. Maybe do that 3 or 4 times. And whatever distance is the furthest, whatever distance this thing travels that's the furthest, is the one I'm going to take. That's because when I release the rail, I can sometimes hold on to it just a little bit and not get a very good release and cause it not to go as far. The furthest distance it travels will be the one that had the best release, and it's the best release that we're really after. As long as I'm sure that I've measured this distance correctly, the length of the rubber band, then I'm safe in taking the distance, the furthest distance. Now all those distances were about the same, so I probably either had equally bad releases, which is unlikely, or I had good releases. I can pull the system back further, and of course it goes much further, doesn't it? Okay, by measuring the stretch of the rubber band, I'm going to be able to determine the force that was required to stretch it. And then I can determine things about the force times distance product of the rubber band, and that's something you'll have to read about. I'm not going to explain that right here, because that's something I kind of want you to discover. Now, the point is that there's a force acting through a distance here. It's a variable force because the rubber band doesn't always have the same force. And we want to see how the force times distance product, what we get when we multiply force times distance, or average force times distance in this case, relates to how far the rail slides. And another thing we need to measure is how much resistance the rail has to sliding. For that I take the small rubber band and I'm going to slide the rail along here. What I'm going to do is I'm just going to kind of watch. There are little bits of unevenness on the rail edge, and I can kind of focus on those and see where the average position at the end of the rubber band is as I move across. Then I'm going to take a marker, and I might actually tape a little piece of paper on here that I could mark. Might even tape a piece of paper with some marks on it. And I'm going to make a tentative mark, and then I'm going to slide it along again and see if the end of the rubber band stays at that mark. And it seems like it does. Then by measuring the distance from this edge over to here, and remember I've got the rubber band held by a paper clip here, and just around one edge, okay, the lower edge here, just one edge of the rail, and as high on the rail as possible. Then by measuring this, I can measure the length of the rubber band, and I can compare that to the length of the rubber band in the calibration process that we used earlier. If necessary, I can recalibrate the rubber band. I could even suspend the rubber band and hang weights until I get the same stretch that I observed here. And from that, I'll be able to determine how much force it takes to slide the rail across the surface.